Good afternoon and welcome to today's webinar on fuel cleanliness in mining, hosted on behalf of Donaldson, the largest provider of unique filtration technologies and high-quality filters and parts. My name is Shannon de Rehove. Before we get started, please note the chat and the Q&A are available to you. Please post your questions in the Q&A and your comments in the chat. Both the Q&A and the chat are at the bottom of your screen. Please also be aware that we're recording this webinar and we'll send the recording to you when it's available. We're also streaming the webinar live on YouTube. Today's panel will explore the impact of fuel quality on mining equipment and best practices for fuel filtration. The panelists will offer expert insights and practical solutions to ensure your fuel stays clean, to protect your fleet, because contaminated fuel can cause equipment failure, downtime, and costly repairs. The speakers discussing this topic include Donaldson Filtration Sales Manager Santiago Rodriguez, Donaldson Filtration Product Manager Tuto Secreto, Liquid Rock Process Solutions Sales Director Kathy Malama, and Liquid Rock Process Solutions Engineer Manager Mwansa Mulenga. So without further ado, I'll hand over now to our panelists to start the discussion.
Hello, good afternoon, everyone. Can you hear me okay?
All good.
Perfect. So I want to start off with a question. What if I told you there's a way to reduce your scheduled servicing and downtime by more than 85%? To me, that sounds pretty ambitious. But in mining, where every single second of downtime costs money, and every repair that we have also eats into our margin, is not only possible, it's absolutely essential. My name is Santiago Rodriguez Jastram, and I'll be your host today. Today, the session is not just another webinar. It's a strategic conversation about unlocking hidden efficiencies in your operations. And the key, something as fundamental as fuel cleanliness. We're excited to host this session with experts from Donaldson and Liquid Rock Process Solutions, our partners. They'll delve into how advanced filtration technology and strategic partnerships can directly enhance your bottom line and operational uptime. Now, let's go meet the panelists who will guide us through achieving this outcome. I'll just remove myself from here, not to bother you guys. So first of all, we have my colleague Tuto Secreto, and I'm very happy to introduce him as a product manager for the EMEA region. Tuto has over 8 years of experience in product management, technical support, and sales. Tuto specializes in filtration, product, and business development. As a product manager for Donaldson EMEA, he leads a clean fuels product line, focusing on innovation, cost improvement, and cross-functional collaboration. Next, we have Kathy Malama. I'm very pleased to introduce the sales director of Liquid Rock Process Solution. Kathy has over 20 years of experience in sales and marketing. She leads and fosters strategic supplier partnerships to exceed customer expectations and drive revenue growth. She holds an MBA from the Management College of Southern Africa. As well, we have her colleague Mwansa Mulenga. He is from the technical team, and he will explain briefly on the solutions offered and favorable results achieved with our solutions. Mwansa has been with Liquid Rock for over 5 years and holds a Bachelor of Chemical Engineering. Now I'll give a bit of background on myself. Let me see if I come back on the screen. So, as I said, my name is Santiago Rodriguez Jastram. I studied mechanical engineering, and I started off in the company as an engineer. I had a similar position to Tuto had in the past, and I was also specializing specifically in clean solution from a technical standpoint. And I have to say, it is a really beautiful product line, especially because of the benefits that is quite tangible and measurable for your operations. Now I shifted into a commercial role, and I am the manager of the sales team for North, West, East, and Central Africa. Now I will play you a quick video. Instead of talking too much about Donaldson, let's talk about Donaldson within the context of mining. So I'll play you a short video. Don't worry about it. It's only going to be around 40 seconds or so. Let's see if this plays. There we go. So the idea is that we see our products through the lens of mining specifically. And this goes through all sort of product categories that we have. So first of all, we have, of course, the air filtration, where we absolutely lead in media technology. As well, fuel filtration, this one is on board, on the vehicle. Lube filtration, also for the lubricants within the vehicles, and hydraulics as well. The last one, and that is the subject of today's seminar, is the clean fuel and lubricant solution. And to briefly summarize, as you might already know, this one is not on board. It's of the tank and fuel storage that we have. Now, again, we are dwelling into specifically clean fuel filtration technology. And the idea of this is to reduce unplanned downtime, protect your high-value equipment, and improve the total cost of ownership. At the end, it comes to saving costs. Then we'll shift to the field, where our partner Liquid Rock brings the technology to life. So for us, it's key that you not only listen from us, the technology and the products that we have. For us, it's key and fundamental that you hear from peers in the market what their experience is. Our goal today is to give you a clear, actionable insights that you can also apply. So again, that's the marriage that we want to do between theory and real-world strategies. At the end of the day, performance is proven at the mine site, not in a brochure or a spec sheet. We can see spec sheets, we can see a lot of flashy and beautiful proofs of products, but at the end, if these results that are done a lot of times in labs are not validated against real-world mining operation, they lose a lot of value. That's why we at Donaldson really strive to get these results always validated with customers in field where the real world actually lies. Now, our priority is keeping the operation running. Again, is not only about saving you money and improving the TCO, but it's also reducing your downtime. And that's why partnership comes in. It's not only us, it's us together with you. At the core, our goal is to help you move the business forward. That means optimizing survey kits, ensuring clean fuel at every stage, and validating our impact to real-world field trials. Now, I'll hand over to my colleague Tuto, who will take you through how implementing fuel cleanliness helps you on your operations. I'll stop sharing now.
Thank you very much, Santiago, and good afternoon to everyone. Thank you all for joining the webinar today. Today, I will be taking you through the benefits of having clean fuel, and we will also look at the importance of ultimately ensuring that we meet the desired ISO cleanliness levels and look at the benefits ultimately of clean fuel at all times in our onboard equipment, going onto our equipment. So first, we look at fuels itself. We normally see that fuels, when they are produced or when they are manufactured, they're actually as critically clean as they should be. The problem starts when the fuel gets into our distribution channels. That's generally where we start seeing contamination. So when we look at the downstream side of the value chain or the transportation of fuel, we see that it tends to exchange hands quite a few times, and we see that it's getting transferred into various parts. We see transfers through trains. We also see this transfer happening through bulk storage tanks. And ultimately, what then happens is that we now ultimately reduce our fuel quality, or we see the fuel quality degrading over time as it is being transferred from all these various points, and ultimately creating a bit of a challenge for our onboard filters or our on-engine filters. Generally, our on-engine filters, we want them to perform as optimally as possible. Hence, we need to ensure that we feed clean fuel in these onboard engines of ours. We generally have what we call a desired ISO cleanliness level or desired ISO target that we should have before we go onto our onboard equipment or on our onboard filters or onto our machineries. Generally, the filters that are on board, they require a known ISO code or ISO cleanliness level. This way, they can ultimately protect our crucial components such as the high pressure common rails, our injectors, and our fuel pumps. And what we say is that that ISO cleanliness that we desire must be cleaner than the worldwide fuel charter. We will delve deeper into the worldwide fuel charter and understand what it is. But first, we need to understand what is this ISO cleanliness code that I'm talking about. Bringing it into context, ultimately, I can say that the ISO cleanliness is there to tell us how clean our fuel is and the quality of the diesel or fuel that we've got. So what we've seen over time through research is that we get an ISO cleanliness level generally sitting at 22, 21, 18. This is mainly because, as I mentioned, that as fuel exchanges hands far too many times, it tends to generate contamination and start getting contamination. And the desired target for us, as we've noted, the evolution of the diesel engine, the target that we see today for our ISO, for our engines, is that we should at least have a cleanliness code of 14, 13, 11 before our onboard filters actually start doing the work. As we said, the aim is for our onboard filters or on-engine filters to perform effectively to ensure that it protects our high pressure common rails. So bringing to context again, this ISO cleanliness level, what that is, it is ultimately us taking 100 milliliter fuel sample and basically counting the dirt particles within this fuel sample. In general, it is depicted in 3 different numbers. First, we've got, let's look at the typical delivery, which says that the ISO code is sitting at a 22, 21, 18. So this is basically the code, the cleanliness code that we've got as a typical delivery of diesel. And what we say is that the first number that we see there, the 22, it basically tells us in this 100 milliliter sample, particle sizes that are 4 microns and larger. And then the second number, which is 21, it would tell us particle sizes that are 6 microns and larger in this 100 milliliter sample. The last number, 18, basically gives us it gives us particle sizes that are 14 microns and larger. Our aim by introducing filtration is to ensure that we ultimately drop the ISO cleanliness code as low as possible. Today's engines give us a target of about 14, 13, 11 before the onboard filters start working or before they start actually doing filtration. But we see the worldwide fuel charter generally coined, last revised, what we see is that it was revised around the 2009s. A lot has happened since then. So the 18, 16, 13 cleanliness level that we see, according to today's engines, is actually not sufficient to meet the performance and ensure that we've got the uptime that we desire. Let's look deeper again into this cleanliness codes that I'm mentioning. So when we talk about an 18, 16, 13, what does that mean exactly? So we said the 18 tells us the first number on the code, which is 18, tells us the dirt particles that are 4 microns and larger. So in this 100 milliliter sample, when we've got a code of 18, 16, 13, what we ultimately see is that we've got particle sizes that are 4 microns and larger. We've got about 250,000 of them in that 100 milliliter fluid sample. And then when you look at particles larger than 6 microns, we generally see that we've got 64,000 of them. And then so on the 14, we see there's about 8,000. Our idea is to ultimately drop the ISO code to a target of 14, 13, 11 before it goes onto our engine. That is the target that we desire. to ensure that we've got clean fuel ultimately operating. Interesting thing that I found as well on this that we found in this ISO code is that if you drop the ISO code by one number, so dropping it from an 1816 to a maybe let's say a 1716, 1715, you ultimately are dropping the dirt particles by half. And then if you increase it by one, or if it goes up by one, you're ultimately doubling the dirt particles in that particular fluid sample. So we generally need to be very cautious of that and ensure that ultimately we drop the ISO code as slow as possible, ultimately to ensure that we've got clean fuel going into our equipment and ultimately leading to us having a more effective engine or more effective performance and productivity from our equipment. Ultimately, why has the ISO code gone down drastically and why do we need clean fuel? We've seen a lot that has happened generally. So because of legislations, and we've seen strict legislation coming into play, and we've seen as well, according to environmental laws, that we require a cleaner environment, a cleaner planet. So we have seen the introduction of ultra-low sulfur diesels. We've seen sulfur being removed from the diesel. We have also seen the introduction of alternative fuels, as we see some organizations trying to target net zero. So we have seen that also coming into play. Ultimately, this has become increasingly demanding for our filters or for fuel filters to ultimately achieve cleaner fuel. And not only did the fuel develop, but we've also seen an evolution on the diesel engine itself. We started seeing the introduction of high pressure common rails when we move away now to Euro 6 engines or tier 4 final drives. Hence, we say the worldwide fuel charter target that was coined of 18, 16, 13 is actually might not be sufficient for our for the components that we're dealing with. We're starting to see high pressures from the diesel injector itself. The diesel injector, the injector has actually shifted from being a mechanical component. We now see it as a more complex electrical component that desires extremely high fuels, high quality fuels that are cleaner, much cleaner. So if you think about it, the operating pressures are now sitting at up to 2,000 bars operating pressure. So the critical quality of fuel that we need there is extremely high. To bring it to context, particles that cause damage to our injectors in today's injectors are as small as bacteria and as high as red blood cells. Just to bring it to context to you, as you see, we say 2 micron particles as of bacteria. To bring it to context to you, what we can see with our naked eye, the lower limit of visibility is about 40 microns. That's the lower limit of visibility. So the particle sizes that we are trying to eliminate or remove to ensure that we've got ultimate performance and we actually have productivity on our engines are not even visible to the naked eye. These are the particle sizes that we're trying to target. So what have we seen? We have seen original equipment makers as well as fuel injector manufacturers telling us that we need to ensure that we've got extremely high fuel quality to operate these sophisticated components such as our injectors. So they give us a cleanliness code of a 1296 to operate these high pressure injectors. In order for us to achieve this 1296, what we're ultimately saying is that we need to go lower than the worldwide fuel charter of 18, 16, 13 to achieve the 1296. So the target that has been set out for diesel nowadays, we're saying from our storage tanks, what we would like to deliver onto our equipment from our bulk storage tanks is to at least have a 14, 13, 11 cleanliness code from our diesel. This is to ultimately ensure that our injectors get the desired quality and that we can have our own engine filters operating as efficiently as possible to achieve the 1296 that we desire. And we at Donaldson have accepted the challenge, and what we ultimately said with our product line that is used in this particular department, we can actually drop from a typical delivery of fuel of a 22, 21, 18. We can reduce our cleanliness target to ultimately to a 14, 13, 11 that is desired before you go on engine applications. Ultimately, what we say is that we are going to drop from 4 million dirt particles, we can reduce to 16,000 dirt particles in a 100 milliliter sample. This is the target that we've actually set out in one single pass. So if you think about it, in fuel applications, you only get one opportunity and then the diesel is in your equipment. Unlike with the lubrication where you can circulate it, with fuel, you only get one single pass through the filter. Hence the importance of dropping the code. And how we achieve this? We achieve this by introducing various Donaldson, the various technologies. So the first technology that we see is the Donaldson electrostatic reduction technology. What that generally is basically is if you take fluid and you operate it at flows of about 100 liters and above, 100 liters a minute and above, it tends to generate an electrostatic discharge. What then happens is that this electrostatic discharge would burn holes in your media, ultimately reducing the efficiency of a filter. Example of this, if you take a 4-micron element at high efficiency and it experiences this electrostatic discharge, it will ultimately be letting particle sizes larger than this 4-micron go to your component or onto your engine, ultimately making it difficult for us to achieve the 14, 13, 11 cleanliness target that we desire. So this is why we introduced this electrostatic discharge technology to ensure that we maintain the performance or the performance and the efficiency that we desire throughout the life of the filter and avoid this electrostatic discharge phenomena that we see. And then we then package this together at Donaldson and we actually coined an ethos that we call clean, protect, and polish. In general, what we say is that we need to know the quality of diesel that is going into our assets. So ultimately what we say is that when it is being delivered, we saw the typical delivery of diesel sitting at a 22, 21, 18. So when the diesel is delivered into our equipment, into our large storage tanks or our bulk tanks, we say we would like to clean it. This is the most effective way to actually reduce the ISO code to get the desired 14, 13, 11 that we need on the outlet into our equipment. So we first clean it and ensure that we remove any dirt particles. And while it is dwelling within our custody as well on our sites, we need to ensure that we protect it. How do we protect it? We ultimately protect it by having a strong breather program to ensure that we protect it from any of the outward conditions. We protect from moisture intriguing our tank. We also protect it from any possible ingress that could exist from the atmosphere. And then lastly, this is where we need to now put the ISO cleanliness levels beyond reasonable doubt. We need to polish the diesel and ensure that we meet the critical cleanliness target of that 14, 13, 11 that we desire or better. And then we then transition now from function to product, and we show the various products that we've packaged together in this clean, protect, polish to achieve the target that we say of 14, 13, 11. So on the clean side, generally, as we saw that we are dealing with very high contaminations, they're over 22, 21, 18. What we then say is that we would like to introduce larger vessels there. So we are generally also experiencing deliveries of fluids at very high flows. This is generally offloading through a road tanker. That's what we see. So flow rates generally are higher in that particular instance on this particular side. And what we see is that the quality of diesel is generally dirty, as I already mentioned. So what we do is we introduce a bit more open filters like a beta 2007 micron spin-on element. Not only do we target particulate, but we also target the second biggest enemy of a diesel, which is water. We do that by actually introducing the blue vessels that you see there. They mainly are fuel water separators. So any traces of water that could exist in the diesel that we are filtering, we would actually separate it using these fuel water separators. And then ultimately remove particulate with our manifolds that's got 7 micron filtration that also contains Donaldson electrostatic reduction technology. And these vessels that you see here, they are actually scalable. So if you've got higher flows, we can scale them together, fit them in 2s or 3s, depending on the site conditions that we've got, but we can actually scale it up and down accordingly. And then the other thing that we mentioned, we said we would like to protect the diesel while it is dwelling within our custody. What do we ultimately want? We need to ensure that we've got clean, dry diesel. So the picture that we see on the top left, that's the desire that we want, clean, dry diesel. But knowing the conditions that we've got in the mining space, as we saw in the video that Santiago demonstrated, there tends to be a lot of dust generated. And then if you think about underground conditions, we generally have higher levels of moisture there as well. So if our tanks are dwelling underground, we also run the risk of actually getting moisture into those tanks. In order to ensure that we've got clean, dry diesel, we then need to ultimately have a strong breather program fitted in place. Generally, we want to ensure that we don't have ingress and we don't have any water that is infiltrating our large storage tanks. And this can actually be achieved by introducing a breather. So the breather that we have here is developed also through Donaldson technology, is a trap breather, which is ultimately a thermally reactive advanced protection. There are various benefits to this breather that we put up here. One that I can mention already is the self-regenerating capabilities of the breather. Another thing that we get out of this breather, it's actually giving you an opportunity not only to remove particulate, but it captures any forms of moisture that could exist in the atmosphere. So if we think about the inner workings of a tank, of a large storage tank or bulk tanks, when we think about it, when you remove diesel, ultimately filling your vehicles or your equipment, what then happens is that there's a void created, right? So that void needs to be filled in. So what happens is that the tank would tend to suck in atmospheric air. When it is sucking this atmospheric air, we do know the conditions tend to contain dust. There tends to be moisture in the atmosphere as well. So generally, the tank would suck in that dust in. So in order to ensure we don't get contaminated dust or moisture in our tanks, we ultimately introduce this trap breather that's got these three benefits that I mentioned. And then ultimately, when you are now filling the diesel into your large storage tank, what we would then see is that the fluid, new fluid is coming in, and then the air would then dissipate or leave our tank. What then happens is that when the air is being dissipated and removed from the tank, we would see the breather tend to self-generate, ultimately pushing out any of the water that it had captured, pushing that out, ensuring that it self-regenerates, ultimately leading to the longer life of our breather as well. So we're not only removing particles or trapping particles, but we're also removing any possible moistures that could infiltrate our tank during the inhaling process or during the intake process, ultimately having clean, dry diesel dwelling in our custody throughout the life of our diesel. And then to put it beyond reasonable doubt and ensure that we meet this 14.13.11 ISO cleanliness code, we would then polish the diesel and ensure that we've got the 14.13.11 or better. And we achieve this by using extremely high efficient filters, 4 micron beta 2000 spin-on elements. Generally, on this outlet, what we see is that the flows are extremely low. So what we do is we plumb the two, we connect two spin-on filters together. 4 micron dirt particle, removing any possible traces of dirt that could exist. But then we introduce a second one in series, which is targeting the second biggest enemy, which I mentioned is water. So any traces of emulsified or free water that could still exist in the diesel would then be captured by this second filter that we put in place, which contains super absorbent polymers. I often get a question about this water absorbing element of ours. Why does it not have a drain valve at the bottom, similar to what we've got on the clean side with our vessels? The reason for us not having a drain valve here is because we are dealing with water absorbing elements. What then happens is that the water is actually retained. It's actually retained or it's absorbed by the element itself. It's not separated or coalesced like what we have on the clean side. Hence, there is no water to drain. Ultimately, when you go to the filter, there'll be no water to drain out. It has actually been retained, so the media swells up, ultimately reaching restriction, but there is no water to be drained in this particular instance. But in general, putting this clean, protect, and polish together, we would ultimately have clean, dry diesel going to our equipment and our machinery, ensuring that we meet the 14.13.11 ISO cleanliness target that we desire through using this whole clean, protect, polish. So all of this being said, what I can say is that this Hold, clean, protect, polish is not a substitute for poor maintenance. We also need to play our part and ensure that we practice good maintenance practices. So if our filters are restricted, we need to ensure that we replace them. We need to audit our infrastructure. That's a very, very important thing that we must do as well. If there are any leaks in the system, that could be where particulate infiltrate our large storage tanks, our assets. So we need to ensure that we attend to any leaks that could exist. Ensure that we close service covers. If there are any open service covers, we need to close them and ensure ultimately we don't give an opportunity for dirt to infiltrate our tanks, or for moisture, in this instance, to infiltrate our bulk storage tanks. This way, this is how we can achieve the desired cleanliness code of the 14, 13, 11. If you put good maintenance practices and the clean, protect, polish together, you can ultimately achieve harmonious motion and ensure that you keep the engine operating. At the end of it all, we all want to have optimal operation. As Santiago mentioned, we want to ensure that we keep the engine moving. We ultimately are more productive so that we don't have any premature failures or unplanned downtime. That's the worst thing that we can experience. We don't want unplanned downtime. Other thing that we want to eliminate is component failure that happens unplanned. So what we say is that when we engage into this partnership, into this strategic partnership together, we need to actually document all the data that could exist. So if there's any pre-existing wear, or if there's any particular problem that we are suffering, we need to know so that we can put this clean, protect, polish specifically to target the issue that we have on site. Because it's no use that we put this filtration. It's similar to saying that we don't want to, filtration is not a substitute for poor maintenance. Also, in this instance, knowing what we are dealing with, ultimately we can put together a package and know how we would measure success. For example, if we know the current ISO code is sitting at a 22, 21, 18, we would know that our target or success would be 14, 13, 11 or better. And ultimately we would keep the engine turning, and as I conclude, say we would be making friends. Last point that I always ask is, where do we want to feel the pain? I always put up this question and say, is it better to replace a spin-on filter, or would you rather experience the pain by actually having to replace a failed injector? If you think about it, you've got an asset out of service, mainly due to contaminated fuel that could have been addressed on the bulk storage tank. So in order to avoid the picture that we see on the right, we ultimately say we need to clean, protect, and polish, and ensure we've got the 14, 13, 11 cleanliness code that our equipment desires, so that the onboard filters can give you the 1296 that has been set out by the OEM. And then with this, I conclude, and I would be handing over to Kathy. And if there are any questions, I would address them at the end of the presentation. For now, I say, Kathy, over to you.
Good afternoon. I hope everyone can see me and can hear me.
We
All
can.
good, thanks, Kathy.
Thank you. Thank you, Tuto. Thank you, everyone, for joining this webinar, for finding time in your very busy schedule to join us. We have heard from Tuto on the product benefits of using Donaldson bulk filtration technology. And as Liquid Rock, we want to demonstrate on the practical side, on the successes that we've had in this market and the few installations that we've had. Let me just give you a quick overview of Liquid Rock. So Liquid Rock has been in business since 2000. It is fully registered and operational in Zambia, and our offices are in Kitwe. We have plans of opening up a satellite office in the Northwestern province to cater for the new copper belt. Where we are at the moment, it's deemed as the odd copper belt because we've got odd mines like KCM and Mopani, which are still viable though. And we've got new mines like First Quantum, Barrick on northern part of Zambia. So we will open an office there, but nevertheless, we're able to service our customers from our central point in Kitwe. We go as far as Southern Province, Central Province, and Northern Province. As Liquid Rock, we have a network of strategic partnership with blue chip OEM brands like Donaldson. And I believe that because of these partnerships, our success has been guaranteed because we're dealing with OEM brands. Markets covered include mining, which is open cast and underground. And we will appreciate that Zambia's economy is driven by mining. So you will see that 70% of our business activity is mostly centered on mining. We do cover energy sector, agriculture, transport, utility, and other industries. So as Liquid Rock, our vision is to be the most preferred and trusted resource of products and services in our market, which we are realizing with the help of the partnerships like what we have with Donaldson. It's been a fruitful partnership. We've been with Donaldson for over 19 years, if I'm not mistaken. This snapshot is a footprint of the customer base, what we cover in Zambia. We cover most of Zambia and some parts of DRC. You will see First Quantum Minerals is one of our biggest customers, Barrick Mine, Mopani, all the mining companies, I must say. We go to as far as the coal mines in Mamba and Zambia Sugar, which is Ilobo. So we are there, agriculture, you will see that there is Zambif as well. So we practically cover all industries. We are on the ground. This slide shows, as earlier mentioned, the strategic partners that we have as Liquid Rock. Donaldson, of course, that's why we're here. Donaldson, through Donaldson, our product offering is filtration. And the filtration solutions we get from Donaldson cuts across all industries. So it's not just bulk fuel, which is the topic of today, but we have other technology from Donaldson as well. Air cleaners, we do hydraulic filtration. From the industrial division, we do dust suppression units or collection units. So we cut across all industries depending on your requirements or challenges that you are facing on sites or what you want to achieve or what equipment you want to clean. We have a solution from Donaldson. We go on site, we do site audits, we assess what your requirements are, and we sit down with our product specialists from Donaldson and offer a solution. So the solution that we will offer you in terms of filtration is customized. It's not a blanket solution. It just depends on what your requirements are in terms of filtration. As Liquid Rock, you will see, I think in the slide that we'll show later, we keep stock of all the filters or installations that we have on site. As we see, Donaldson is a fast-moving product, so it is important or paramount for us to keep stock in order to service our customer at the possible shortest time. FL Schmidt is one of our partners. We do pumping, Krebs pump for slurry solutions in milling circuits and other process plants. Samco pumps, which is done through some engineering. This is a solutions pump which does acidic media, concentrated acid. It can be dilute acid, it can be water. Through Surumi, as our strategic partner, we have a dewatering submersible pump, which is for clear water, for dirty water, or acidic media, but submersible. Franklin Electric, we have quite a range of solutions there. We do pit dewatering, diesel-driven pumps, can be mounted on a skid or pontoon. They can be electrically driven depending on site requirements. We've got quite big installations at Malundwe Pit at Barrick. Ego Bergman, we have sealing solutions where we offer mechanical seals, gland packing gaskets, rubber bellows, metal bellows, all for non-acidic or acidic media. So we offer a complete plant solution. Through FL Schmidt, we can start from crushing, grinding, flotation, thickening, separation. So from the time you start digging for your material, for your copper, for your gold, or whatever mineral that is, we've got a product from FL Schmidt that will help you until you get to a point where you sell off your product. So as Liquid Rock, we're proud to say that we don't just sell a product, we sell a solution. Our core business factors. Over the years, we have built a reputable name. Liquid Rock in this market is now a brand. We're well known. We are a cover our markets well. We have got local presence and we have running contracts with major mining companies. We understand the terrain. We know the customer base. We know what they require now. Our reputable name is known for good business ethics, for over excellent service. We have got experience in managing customer contracts. We've got running contracts with the likes of First Quantum and other mines for filters even. And we've got technical expertise. We've got, like my colleague who's going to come after me, we've got a technical team fully trained, for instance, by Donaldson to go to sites to offer you technical advice, troubleshoot, find out what your problems are in terms of filtration, and advise what best suits your requirements or your site requirements. Donaldson, fortunately for us, is a good partner. They train our team. They offer training also to customers. So it's one of the aspects that make Liquid Rock stand out. We offer customer training as well. As we are trained by Donaldson, we also cascade that to our customers. So you will see on in this slide on the pictures, on the right, we've got our guys in the workshop. We've got repair capability. We've got a repair workshop. Our guys there are working on a barrier assembly. Down there, the other picture at the bottom, our guys are building up a pump MM700 for Barrick. On top, you probably can't see the gentleman there. He's hidden behind the pipes. That's one of our guys doing the installation at Lublend for filtration. We did this product, I think Mwansa will talk about it. So again, we don't just sell a product, we offer a solution. If our clients are not able to install the filters, we've got a technical team that will go and do the installation, the pipe work for them, and ensure that the filters are properly installed so that the customer can achieve the benefits that Tuto and my other colleagues were talking about. At the bottom there, you will see we've got a picture of our warehouse. That is to demonstrate that we keep a lot of Donaldson filters in country. So when you start using this product, in case you're not on our customer book, you are assured that we've got stock available and we'll service you at the shortest possible time. I think a small picture there shows one of our field guys on site. This is also to demonstrate that we are on the ground. We get to the customer at any time. Our guys are on call 24/7. That's what we usually say. And so when there's a problem, we immediately go to site. And this is one of our guys who went to, I think this is Barrick. And so this slide here is just a sneak peek on the few filters that we have installed on site that have proven to have sorted the customer problems. The sites that Mwansa is going to talk about where some of these filters have been installed include Mopani through Puma Energy, Trident, Kansanshi Mine, Total Energies, Barrick, Kajam, Loopland, Zambif. Also, I know we're talking about mining, but Zambif is there just to demonstrate that we cut across industries, that Donaldson has got a complete range of solutions, not just for mining, but for other industries as well. So the popular kit P506073 comes as a kit complete with the water absorbing spin-on, bag fill filter, head assembly adapter, and we have DBB 8777, 8665, 8664, P583359. You probably have seen this in Tuto's presentation, some of these filters, but this is just to demonstrate to you that they have been proven. We have installed these as far back as maybe 2006 on some of these sites, and our customers have given us a positive feedback. We have seen on different sites, I may not mention the sites, that in comparison to competitor products, they gave us a feedback that our filters improved their flow rate at point of sale. There were no issues of rupturing of filters. They had issues where that competitor filters were rupturing suddenly. And also they have seen a reduced change out, less downtime. And so on the overall, the total cost of ownership had improved. So this is a few examples I can give, but I will move over to Mwansa, who's going to give us a few examples of different sites that have been successful. Thank you very much.
Hi, I hope everyone can hear me loud and clear. Yeah, just want to say thank you for Tuta and Santiago for the technical background on the bulk filtration. Before I go into my slides, I just want to ask everyone, what's the cost of a change out of an injector for a big mining hole? I mean, you don't have to give me the answer now, but I want you to have that at your back of your mind. And how long does it take one to change an injector? What does it cost the company, the industry? And how long would you get that machine back to work? So we're going to look at some of the practical success we've achieved with Donaldson. We'll look at Puma Energy. Puma Energy is one of the main suppliers for a mine called Mopani. And what we were tasked to do is to help deliver quality fuel. I mean, what do we mean by quality fuel? We need to clean it, we need to protect it, we need to polish it. So we stored at the receiving bay. At the receiving bay of the farm tanks, we installed breathers to protect the tanks, and then we installed filters at the dispensing. This process is very cardinal because it now ensures that we are able to achieve and deliver fuel to the recommended specs. ISO desired cleanness. They were looking for an ISO desired cleanness of 18, 16, and 13. I know Tutu mentioned earlier that we as Donaldson can achieve a far cleaner level than this, and which the mine and other industries are happy. So this is one of the success stories we've actually done, and it's proven. And it's also a cardinal to notice that we do take tests when we start the project. It is very cardinal to have that information, and we track our filters, change outs, the quality of the fuel, and also see what other savings the mines will serve. Lublend, this is a bulk filtration system we installed using one of the manifolds. This is a 4 by manifold. We installed 8 manifold. Why did we do this? The mine demanded a certain level of cleanness of their loops and ores that were being transported and using. So after installing these, we were able to achieve the ISO standard that was both accepted by the mine and the Lublend team. We continue supporting these by regular checks and also giving technical support. It's not just, we just don't dump the product there. We continue working together so that we continue selling the success story. Kansanshi mine. This Kansanshi mine have got a fuel tank run by Total. So what do we do? What do the filters do? So we look at cleaning the fuel from the source when it is delivered into the holding tanks, how it is stored, and how it is dispensed. Then one would wonder, but what happens when you transport your fuel from the farm tank maybe to the pit or underground? All the bowsers there have also got a Donaldson solution. We ensure that even during the process of transporting the clean fuel, we add protection, we add a breather to the tank, we add filters so that when the fuel is being delivered at the point of service, you would have a clean fuel. So this has been done, and so far we have saved the mine a lot of money. There's less downtime in terms of maintenance of their trucks or the equipment that is using the fuel. We look at Barrick. Barrick Lumwana is another mine where we are busy working with them, where we are cleaning their fuel, polishing and protecting. Same process as Kansanshi. We install filters at the initial point of where they receive fuel, how they store the fuel, and how they dispense the fuel. The critical things you have to look at, you need to look at the capacity, the volumes, and then as a technical team, we size up the right kind of manifold or system. Each system differs from site and the demand they require. Just rushing through, and then this is just showing, apart from the mine, we had one customer, a farmer. He had a problem with the combined harvester. He says, listen, I'm changing my 32,000 injectors every now and then. What did we do? We went there. We did a test on the fuel before we installed. We showed him the quality. We did a size up of what was required on his fuel farm tank, installed a Donaldson system, and after that, we gave him the results. It was tremendous. Up to now, he's a happy guy. So in a nutshell, just trying to say, we thrive on Donaldson delivering what it says. I know Santiago, when he started, people were thinking maybe this is a fairy tale. No, we've got facts that can back our story, our journey, and that's where we are. And then as Liquid Rock, we're not just a provider, as Kathy alluded. We offer technical support, on-site training. We stock all the critical filters on site. And when you need us, please contact us. We'll work together with you to solve the problem. What is your problem? Are you having issues with your field? Give us a call. You know what? We will have a solution for you. So thank you for the presentation. I'm going to hand over to Santiago. Yeah, just to wrap up and add on.
Yes, I'll take over from you.
Yeah.
Can you see my screen now?
Yes.
Yes.
Perfect. Kati, Mwansa,
Yeah.
thank you so much. You really had a very valuable insight, and I think there's a lot of value when we do these combined webinars. And I also want to congratulate somebody else, even though we're not yet at the end, and that's everybody that's in attendance. I've been reading the questions, very good questions from this group. Please keep them coming. Remember that not only you can ask general questions, we will do our best to answer them. You can also ask questions to Katia and Mwansa, for example. They have real life experience as a customer as well. So don't let just us be the one telling you. You can also ask them. So these are the last few slides. So bear with me. So at the heart of today's discussion, there is the value of choosing, and I think that's what this slide is about. Choosing the proven partner, choosing the clean fuel strategy, and choosing the trusted solutions that drive the long-term efficiency. And that's exactly what Kathy and Mwansa showcase at the end. And that's what here we as Donaldson are to deliver. Now, a few key takeaways. Fuel cleanliness is critical. I think if you heard Tuto, there's absolutely a key part of having a smooth operation. Donaldson has a proven solution to supply this clean fuel at the end. Real world success. So we don't only talk the talk, we like to walk the walk as well. That means we have real life case studies that prove the effectiveness of the solution. The partnerships, we cannot do this together. You cannot do this alone. We have to work together here. And at the end, what we want is the TCO, the long-term savings and efficiency. At the end, that's what we want for your operations. Okay, now you say, okay, I choose. We're talking about choosing all the time. I choose to improve my operation. How do I get started? So I'm just going to give you a quick flavor of it, not spending too much time in this, but it's basically 3 phases, with the first one being the validation. So we do a survey. We understand what data, what material we're talking about, what kind of issues you're having. Second is the implementation. We survey all the equipments. We do the cleanliness report. And a lot of times during these stages, we have a shock phases because we take a sample of diesel, you look it through the sun, and it's completely clean. Once we see inside, there is a lot of particulate matter that can be very harmful for your equipment. That's why these cleanliness reports are so important. And then the third phase after the implementation is the evaluation. So monitoring and seeing what the value is of this product specifically and improve continuously. Now, one thing that I also wanted to mention is that our commitment not only ends with product, we also offer tailored on-site support. Whether that means ERP, and ERP here just means enterprise resource planning. So if you have SAP, if you have Oracle, we can integrate this solution with it so you can actually see the evolution of it. Stock holding, technical audits, supply chain collaboration. And it was very refreshing also to hear Kathy mentioning about how we support with our technical support and engineers. We make them go to you when you have issues. Not only the commercial team, we also have a very qualified engineering team that can go there and see where your pain is and support you throughout. So through regular planning meetings and hand-on assessment, we help you ensure the filtration solutions evolve with your needs, which can be ever-changing, adding value and maintaining performance where it matters the most, which is on site, not in a lab. So guys, I don't know if you remember, but I started off this presentation with a very simple question. What if you could cut the downtime by over 85% and boost your performance at the same time? I said it was very ambitious. Now, what we have here in the QR code that you can scan, you can take a print screen, is a case study, the Pumas case study. And in that case study, we saw exactly that. So you will find all the information, all the technical details within it. And you will see the dramatic reduction in scheduling services and the operational gains. And again, I want to close up with the choices, because in mining, the difference between being just average and having an average operations and being an optimized operation, there's only one decision to make there, and it's the decision to act. Thank you very much, all of you, for joining us today. We look forward to helping you turn insights into these actions. Congrats once again on the great questions. I think now we can slowly shift to the most fun part of the webinar, which is the discussion part of the Q&A. So I'll stop sharing, I suppose. All right. So let's manage these questions. I can read them one by one in order. Between the whole panel, we'll be striving to answer them. So the first question I see here, corroding internally. Could this be the chemical composition of the fuel or contaminated fuel? And just a quick note there. This question came at 1:04, so at the beginning of the seminar, before Tuto was explaining about the water. So we're giving him the benefit of the doubt. At the same time, please, Tuto, if you have an answer here.
Yes, Santiago. So this ultimately does allude to my presentation. Generally, when you see this corroding, it could be linked to the moisture that exists or water inside the tank. So ultimately, you want to remove it before it even gets inside your large storage tank.
Absolutely, and there's a lot of different mechanisms that we have to remove the water there. The golden standard is that it doesn't even come in your tank. That would be the number one thing, that you don't have it. But this is, of course, not always possible. So then we have the dehydration kits that Tuto talked about that can actually remove the moisture from inside the tank. Thank you for that question. Then we have another question, comment here for Quinton Fersters. Your particle count should be particles per milliliter. Quinton, you're absolutely right. That's how we do ISO codes. Usually it's amount of particles per 100 milliliters, which is a density, basically, of particles of different sizes per volume. So thanks for that comment. So next question from Mahesh Salunke. What is the threshold for water removal vessel? I mean, up to what extent water can be removed? Great question. Tuto, you want to take this one?
Just repeat the question again, Santi.
So this person is asking the threshold of water removal vessel. So up to which point we can effectively remove water?
So generally what we want, as you mentioned again, is to ensure that we've got clean, dry diesel going into our large storage tanks. So ultimately we want to remove the water completely. But again, we don't have 100% efficiency when it comes to filtration, because we do need diesel to go into our tanks again. So up to
Absolutely.
that point, generally we want to remove it as much as possible. And if it still gets through, we can actually remove it through draining our large storage tanks. As we know that water is heavier than diesel, it will settle at the bottom. So if there is still traces of water, it will be removed ultimately through the fuel water separate through draining out our tanks. But generally, we want to remove the water throughout the life cycle of the diesel before it goes into our combustion chambers, ultimately making our onboard filters as efficient as possible.
Great, thank you. And I think one more thing that I wanted just to mention here, because the question from Mahesh Salunke, we have also, when we have water inside of the fuel, we can have it in two ways. We can have it either dissolve within the diesel. That means when you see the fuel, it doesn't look like anything because the water is dissolved. Like when you put a little spoon of sugar within the water, you don't see the sugar anymore. Why? Because it's dissolved within the water. So we can have water in two ways. We can have water dissolved within the fuel, and we can have dropout water. So that's when the point of saturation of the fuel has reached its maximum capacity, and you start to have that deposit of water at the bottom. So that's the two ways. So the first one is a lot easier, and that's what Tuto was mentioning as well with our water absorbent elements. When there's water that is not dissolved, that is actually outside, it absorbs this water and it stops it. But when the water is dissolved inside the fuel, it's a lot more difficult to remove it. The only way to remove the water from that is dissolved is with desiccation, to dry out the air, and therefore the water comes out of the fuel and it gets dry from the fuel as well. Great question. Thank you. Going through the next one. Okay, then we have a question from, again, Rajesh Salunke. What frequency of filter cleaning and replacement is required?
Can I take this one, Santi?
Of course,
and
Tuto.
ultimately say yes. So in general, when we speak about fuel filters, we do not clean them. Once they are saturated, you have to replace them. So frequency of replacement will be determined by ultimately checking your indicators. You've got pressure gauges and you've got restriction indicators. They would actually tell you when the filter is saturated. And yeah, ultimately when it's saturated, that's when you replace. So there is no frequency. It's important to look at your apparatus that's measuring the filter life in this instance.
Yeah, and when a filter plugs, usually it means that it's working, right? That it cut so much dust that there's no more fluid passing through it because it did its work. And I wanna mention one more thing, because here it says, what frequency do we clean the filters? And one of the issues we have here is that the way we build our media, which is a very high efficient media, it acts in a way like a sponge sometimes. So when you have dust within it, you cannot really clean it because it's embedded within the media itself. So cleaning filters usually doesn't lead to good results. Usually what you have is contamination of the clean side of the filter, and that's going into your engine. So cleaning filter is something that we strongly recommend against.
Can I jump in?
Of course.
Yeah, just to add on, I think when you go to site, one of the things you look out for a practical way is if we ask a client, when was the last time you cleaned the filter, the tank? Because I think most people will discover that if you haven't cleaned the tank, we put in our system, you're gonna clog those filters in hours. Yeah, so So and then if you clean, you will see that there'll be a less frequency of cleaning. And definitely we don't clean filters. Once it's clogged, out it goes.
Absolutely. That's such a good insight, Monza. I think at the end, we shouldn't even put the system unless they clean the tanks, because what you're gonna do, you're gonna immediately plug them.
Yes. So we need to look at that. We need to know the history.
Yeah, and as Juanza is alluding to, this cleanliness is not only a product that is a solution, it's a mentality, it's a culture of cleanliness. We have to have it clean from the moment it's delivered to the moment it's in the tank to the moment that we're putting it into our machines. And it's all throughout here that it can get dirty. Great. Next question we have. We can expect some moisture entry in tank from the pressure vacuum relief valve. Correct. How do you protect moisture ingress there? So, Tuto, I'll leave it up to you.
Santi, yes, just here what I can say is I can give a comment that we've got our ARVs, so we've got various apparatus that we can use in terms of eliminating or assisting in this phenomena. But what I can say is maybe the person who posted the question can reach out to us after the session, because I can give detailed insights on this one.
Yeah, absolutely. And again, we have the ideally, of course, when this person is asking the pressure relief valve, when you have a pressure or relief valve, what happens there is that you have open connection to the environment. So there's no way to protect that. It's like because otherwise the tank can explode or implode. So we don't filter when we are, because it's a safety mechanism. So of course you can have that, but before that happens, we have our trap readers, right? And the idea is that if there is no super high flow rate, for example, the this valve should not activate, and everything should go through the trap readers, which I'm gonna just quickly share the screen here. So we see it again. So again, this trap reader avoids the moisture to coming in. So to answer your question, if it's a relief valve, we will have it unfiltered and maybe moist. But for that to happen, it has to be in a situation where it's the safety requirements that the check valve for them to open.
Yeah, and we can share that particular phenomena when the customer or when the person reaches out to us, we can show them the various solutions. Okay.
Great. Other question. For particulate cartridge filters in a case of lubricants, after how many liters should the filter change or replace by? I think we just answered this. So we use usually the indicators, as Tuto mentioned. What is the maximum flow rate possible in case of bulk fuel storage system offloading and dispensing to vehicles?
You want me to answer that one?
Yes, sure.
So offloading to vehicles, I guess, we do have we normally see curbside pumps being used for this particular application. So the flow rate generally comes from there. We have seen it sits at around 189 liters a minute, but generally it would be, you would get this information from your dispensing pump. And then depending on the flow rate, we would select suitable filters. If we need to, we can upscale by having 2 filters fitted together or 1 filter, just depending on the given flow rate of your operating equipment, the pump as well, in this instance.
Yeah, right. Another question. Sorry, Monza, go ahead.
Sorry, Todd. Just to add on, I think it's very important for the customer to understand that we need to know the capacity of the pump, at what rate, and then we've got different types of system that we'll select. So it'll be very difficult. That's why each case is always different from another one. Sorry, just wanted.
Thank you, Monza. Another question here. what is the exact function of fuel polisher? And this one, I'll answer quickly. We have, so basically the way we see clean solutions basically is in 3 steps: clean, protect, and polish. So basically we use the same filters. Clean is when we are getting the fuel delivery from the tanks, from the supplier, Total or whoever, into the tanks. That's a clean part. So when we get a fresh batch of fuel, we get it clean. Protect is what Mwansa was saying. We have to clean the tanks. We have to put that trap reader. So we protect what we're storing. And polish is the one when we're dispensing to the vehicles. So fuel polisher is it's just the way we are saying of that last stage in which it goes from the tank into your vehicles. Great, I'm looking for the next question. Maximum flow rate. So I'm seeing here a follow-up to the sulfur question, but I don't think we have answered any sulfur questions. So I want to make sure that I didn't miss a question about sulfur. Let me just quickly check. Oh, here it is. Yes, sorry, I missed one question from Robert Cusmano. What is the tolerance level for sulfur in ppm for most equipment? And is there any available filtration that would reduce sulfur in fuel? Maybe I can quickly answer that one. Sulfur is basically an additive that it gets usually done in the refinery part of the fuel. So the sulfur is dissolved into the fuel, and just like water that is dissolved into the fuel, we cannot remove it with mechanical methods. So there's no filter that can remove the sulfur from the fuel because, again, it's dissolved. And then we have the modern engines. So as you know, usually the modern engines, they all require the ultra low sulfur diesel, or ULSD. And these ones contain usually 15 ppm of sulfur or less, if I remember correctly. And please, Tuto, correct me if I'm wrong, but I think it's around that area.
Yeah, it varies, Santi, but yeah, 15 is one of them. Yes.
Cool. Okay, now I'll get back to the, and I'm having second thoughts. I really don't want to miss any of your questions, so I'm going through them, coming through them very carefully. Follow-up questions for sulfur. It is very unlikely that a filtration system can reduce sulfur. However, my question would be, is there a process or system that could be utilized to sulfur reduction? Okay, great. Again, I think, and Tuto, also let me know if you have different information. This needs to be done more at refinery level. It's I think difficult for us to convert a sulfur-rich fuel into a low sulfur fuel. I think that without going into complex chemistry, it escapes the scope of what our filters can do. Tuto, I don't know if you have anything additional.
No, indeed, Santi, I agree with you. It's at refinery level where we can actually control the sulfur.
Right. Okay, cool. We have here, thanks for detailed clarification. We reach out to Liquid Rock team for solutions. Great. That's very happy to hear. Another question. Change out of filters is always relative to the cleanliness of the liquid being filtered. If the fluid is relatively clean, the filters will last longer. Correct, 100% correct. If the fuel loop is really dirty, contaminated, the filters will not last as long. Great intervention. And I see here Paul, just Paul. I don't know if it's Paul Pereira, which would make sense. But very right, Paul, in this comment. Absolutely. That's why sometimes it can be counterintuitive, because we do a new installation and maybe they plug pretty quickly. And that means, for example, that the tanks were not cleaned. So of course they're going to be getting plugged very fast because there's a lot of contaminants. But we have to remember that a plug filter, that means that there's a lot of dirt that didn't go to your engine instead.
Yeah.
So because the other alternative is that we do not filter this, and we see this with filtration from competition, that they have, for example, less efficiency. They still use them, and this particulate goes into the engine, and that's where we feel the pain with injection failures and loss of power and all the nasty things that Tuto talked us about. Okay, if I'm not mistaken, okay, we have another question. After how long do you recommend fuel storage tank cleaning? Tuto, you want to answer this one?
Well, I would just say if we implement the clean, protect, polish, generally we should ultimately be having clean, dry diesel dwelling in our asset, right, in our tank. So in general, if we practice good filtration, there should ultimately, I wouldn't want to say no need for us to clean the tank, but we can ultimately be doing it according to the manufacturer of the tank can give us a guideline in that particular instance on when and how frequently we should clean the tank. But that's if we ensure that we've got clean, dry diesel dwelling inside that tank.
Yeah, and I think it's key that we do sampling tests, that we check that everything is running smoothly, that we are doing, we're seeing at the outlet that we have no issues. But generally, if we're putting something clean, like Tuto said, and at the end, we also checking and it's also clean, most likely the tanks are not getting too much debris. But it's always a good practice to at least inspect them.
Yes.
So I read all the questions from the chat. Maybe Shannon can help me to figure out where the Q&A, if it's a different list for that, not that we're missing any of the questions.
Santiago, it looks like most of the questions in the Q&A have been answered. Paul, thank you very much, posted a lot of them from the chat. So I saw you got all the chat ones. So there is, yes, Robert did post one about the sulfur, which I think you did answer. So I think that's everything.
Great. Cool. Any last questions? Any other interventions that we have from your side? I think otherwise we can slowly wrap up the session.
All good from my side. Does anybody have any last words?
I think we're still getting a few questions. Don't worry, we can wait for you if you still have questions. So we have Edric here. How long should water separator filter be changed? Tuto, you want to take this one or should I?
Yes, Santi. I think it also alludes to after how long should we change out our filter. So this is the same thing that we mentioned earlier as well. We've got instruments, as we mentioned, good maintenance practices. We would actually need to monitor our pressure gauges and our indicators to see when the filter is saturated. Then we know that it actually has to be replaced. But we can't put a timeline to it. If the fuel is dirty or if there's a lot of water, it means it will get saturated quicker. And if you've got cleaner diesel operating, it means it can give you long life. But to get the answer, you need to actually monitor and check your pressure gauges and your indicators. I hope that answers you, Edric.
Just to add on, so usually what happens in the mines, The OEM, some of these water separators have got sensors that are linked to the machine that will tell you there's water. And also what we've discovered, the OEM have got service hours. So usually you'd have your 250, 500, 1,000. So these are predetermined by the OEM of the machine when to change these filters. And one of them is water separator, if I'm correct, if that person was referring to a machine or a truck. And I think maybe I've just seen something. Sometimes you may find water in the collars that they're holding. So you can drain that water. I think Tutu,
Yes.
yeah. Yeah.
That's correct. There is a
You don't
water
have to
drain
wait for a
in the
change
water
out. You
column.
can just drain out the water.
Okay.
Right, I see here. What is the OEM recommendations in terms of throughput? And if I understand correctly, the question is about how much fuel can be processed before the filter should be changed or serviced. And I think, again, this has to do with the flow rate, first of all, how much the flow rate is, the filter efficiency, the contamination load in fuel, for sure. But we do have from OEMs, we do get is specific ISO codes. So we get specific ISO codes that we have to meet for their engines. And these ones, yeah, it's below a specific threshold that we have to do it. And yeah, depending on that, your mileage might vary, basically. Another question I was asking based on the fact that we usually dip using the dipping paste and the water finding paste. Doesn't that collect in the tank after some time? That is a very good question. Tuto, do you have any experience with this?
Yeah, so generally, right, the water finding paste where we see it is ultimately if you have water inside your storage tank, that's when you would it would mean that it has actually bypassed the filtration that you put into place. That's when you will find the water using the finding paste. But if you've got the fuel water separator working effectively, and you would not actually be finding any water inside your storage tank if you've got the breather fitted in place and you've got the fuel water separator as well in place. And if you find yourself in a situation whereby with the finding paste you do detect water in your tank, that ultimately means that you can eliminate it either by draining out the tank at the bottom, or the other alternative would be on the dispensing side. You would actually have the water absorber that will help you also capture any possible traces of water. As we mentioned at the polish site, we do fit the water absorbing element as well.
Yeah.
Other option, circulate the tank and remove any possible water as well that could exist.
Yeah, that's also why we recommend routine tank inspections and cleaning. It's
yes,
because maybe it's not the dipping paste, maybe it's something else. So this is a part of, even if you have good filtration, that should be always done. Okay, we have found that dipping paste only detects free water, but not dissolved water. That is why testing for fuel is important. Yeah, absolutely.
Definitely.
So yes, some of the, depending on the testing that we do, some tests do not check even for dissolved water. For example, when we do a patch test, which is the one, or a particle counter, which is the one that we do for the ISO codes, that is actually counting how many particles there are in the fuel. This one doesn't take into consideration the fuel that is dissolved in the fuel, the water that is dissolved in the fuel, sorry. So for that, we would need a different kind of test with a proper lab. I think there is a specific protocol that actually measures the water dissolved inside the fuel. But this is more lab conditions. I don't think, and I might be wrong, that there is any continuous monitoring system that we have in the field that can check for dissolved water in fuel. This would be taken to the lab.
Yeah, I think that summarizes it. Use the lab as well to also check the quality of your fuel on occasion. We do frequent fuel sampling, so the lab is good to give you this insight.
Yeah. Yeah, even sometimes with these pastes, we have issues not only detecting dissolved water, but even emulsified water, which is when you have free water that becomes basically like a mayonnaise. It mixes with very tiny drops.
Mm-hmm.
So Paul is giving here a comment. Paul Pereira. Some clients only add filtration after a few years. By this tank might already have contamination. Good point. So try removing it routinely. If you add filtration, try your best to clean the tank first. That way you can start a fresh slate. Absolutely. Ideally, before we do any sort of filtration, we have a pristine and clean tank.
Yes.
Great. Just checking if there's any other questions on the Q&A or chat. Okay. I wanted to thank you once again, Kathy, Mwanza, and also the team from Creamer Media, and only that, all the attendees. Really, really great questions. Very insightful. I didn't know we had such an insightful attendees on this webinar. It was a pleasure for us to host this, and hope to hear from you soon. Thank you very much.
Thank you very much. Thank you, guys.
Thanks so much. That brings us to the end of the webinar. Thank you to Santiago Rodriguez, Tuto Sekreto, Kathy Malama, and Mwansa Mulenga for an interesting discussion. Thank you to the attendees for taking the time to join us for this discussion on fuel cleanliness in mining. I'm sure you learned a lot, as I certainly did. If you're interested in hearing more about Donaldson, please visit their website at www.donaldson.com. For over 100 years, Donaldson has been solving customers' complex filtration needs and is today one of the largest providers of unique filtration technologies and high-quality filters and parts. The recording of today's webinar will be made available to all stakeholders, and if you have any additional questions, please be in touch. You can reach us at shannon@creamermedia.co.za. Thank you for your time, and goodbye.